11, you learnt about something called straight line depreciation. And that's kind of like the simple interest equivalent. Remember, with simple interest, usually it's an extra amount you're getting or you're adding on, right? With depreciation, the name is meant to be a bit intuitive, right? The idea is that instead of getting additional things, you're taking away or you're losing the value, right? But remember, with simple interest, it's more of a basic calculation where the principle doesn't actually change. That's the same thing with the method that you learned. The straight line method, I put the formula here for you. That's how we use the formula for this one. It's a basic one because it doesn't account for, as this product loses value, it doesn't account for how that changes the calculation. So this is the first method that they'll ask you. It's called the straight line depreciation method. And we say that the item loses value by the same amount each period. Now we know that that's probably not like a realistic way of doing things, right? Like if you buy an iPhone, maybe in the first year it will lose a few $100s. But then the year after that, it won't just keep losing a few $100s, it'll probably lose more over time. And so the idea is we want a better method. And so that's why we look at what we call the declining balance method. So this is something a bit new, right? And this is now saying the item loses value by the same percentage each period. This you can think about as sort of like the compound interest, of depreciation, right? So the idea is we have two methods, just like with appreciation and inflation, those things. You have like a simple interest calculation and you have a compound interest calculation. And that's the same thing that we have with the declining balance, right? When things lose value, right, we can have two different formulas. Now, if you look at this one, hopefully it looks kind of familiar. That looks like the compound interest formula. There's one subtle difference. You know, and see what the subtle difference. Yeah, there's a negative, right? So the only difference here is that we have a negative value instead of a positive. And what that's going to do is that's going to make our total, what we call salvage, or the current value of the asset, lower, right? So they also replace the letters with different things here. That's more of a situational thing, because when you're talking about depreciation, you're talking about things that are losing value now. And so they use these terms salvage, so that's the current value of the asset, so what it's worth right now, and V sub zero, V with a little zero at the bottom, that's what we call the initial value of the asset. So what it was in the beginning, like what it was worth in the beginning, okay? So I'm going to show you how these two problems are a little bit different, and then I'll show you some trickier questions as well. So if you go over the page, we've got a MacBook Pro. Who's got a MacBook Pro here? Yeah. They're costing quite a bit these days. I think $3,200 might even be on the middle or cheaper end. So it is crazy how expensive it is. So we know it's depreciating by $250 each year, and we want to use the straight line depreciation method to find the value after 3 years. Semra, so can you help me out? So what do we know about this MacBook? How much is it worth again?
3,200.
Right, so that would be our V sub zero. That's the initial value, right? D is the depreciation each year, so that would be 250. How long are we checking the value after?
Each year.
Yeah, well,
For A.
Yeah, for A. 3 years, right. So that would be our N. So you can think, hang on, you don't really need a formula for this. It's a little bit of, you could do a bit of a logical way of approaching it. So you don't have to use this formula, but we can plug it in as well. So for example, the salvage value, what it would be worth right now, is $3,200. Take away 250, multiplied by the number of years, so that's 3. You can go ahead and calculate that for me. 2,450, okay. Right. So that's the year 11 method of calculating this. We say that, okay, that's how much it's going to be worth after 3 years, right? If it decreases by 250 each time. What kind of different questions can they give you? Well, what they can do is they can say, all right, instead of saying what will it be after 3 years, I want to know when this is worth $0, right? Oh, sorry, not $0, $1,750. That's the part B, right? How could we do that? Think about what variable this one here is. So I want to know when to the nearest month the equipment will be worth $1,750. What have we got and what are you trying to find? Yeah, Tristan. That's right. You would make that equal to S because that's what you're saying is the salvage rate. Because now you have this piece of information. You said, oh, okay, it's worth this much now. How long will that take you? Well, that's the n variable there, right? So what I'll do is I'll say that this is the same as s, and so I can replace in my formula now. I'll say 1,750 is equal to, now the initial value doesn't change, that's still the same. But what does change is now I don't know what n is equal to, right? So I'm going to just write an n there. Just like that. Okay. Does that make sense? So I'll just say what Tristan said again. He said, all right, well, we have this number here. What is this? This is what I want to know. When will it be worth that amount? I'm trying to find how long it will take me to get that. I'm trying to find what that letter is. Okay. And so again, you can see you've kind of created a little bit of an equation here that you need to solve. Right? Ben, can you help me out? When we're solving equations, what do we kind of think about when we're solving them? How do we solve equations? Yeah. Like if you have an equation like this, how would you solve that? Yeah, you want to make x a subject. You think about your opposite operations and you go from there, right? So the same thing applies here. Even if the numbers are bigger, right, we can apply the same idea. Yeah. Saxon, can you help me out? How would I go about solving this guy? How could I go about solving it? Good, yes, that's the first one. Take away 3,200. Now it doesn't look super great at the moment, but we can fix this up. Should be a negative value there? Yeah. Negative 1,450.
Wait, so what did you do? Take away 1,750? I mean, 200 from that. Is that 200 or
1,750, take away 3,200.
I thought it was a dollar sign.
Okay.
Oh. I blame you. Yeah.
Is that better?
We blame you.
At this point, right, what are we trying to find? We're trying to find the n value, trying to find how long this will take us, right? Nicola, one last step we need to do?
I have to do different ways.
Okay, that's okay. Okay, that's all right, but from here, how would you...
You could divide the right side by
Yeah.
250.
What did you do, by the way?
I just did 1,750 equals 3,200 minus 250 times n, and then did 3,200 minus 250 first, and then moved on to like second.
Oh, as in you did these two subtractions.
Yeah, I didn't swap anything.
Yeah, well remember, you can't quite do that. I don't know why though. Yeah, because this has like an n letter attached to it. Yeah, so you can't, unfortunately, you can't combine those two together. But yeah, but you had the right idea. And so this is going to be how long it will take us. 5.8. Now, with 5.8, right, 5.8 is a little annoying because actually it says when to the nearest month. So remember, we kind of ran into this problem when we were looking at, Ben, something you want to add? You good? We wanted to look at converting, things to time when we had like 60 minutes and things like that. And we're getting them in as decimals, right? This is the same problem here. We have 5.8. I know that means 5.8 years, but they want to the nearest month. So in order to address that, there's a little bit of a trick you can use with this, is that you can grab up your calculator and you can say, okay, well, 5.8, I know it's 5 years and some part of the months, right? What you could do is you can convert 0.8 into months by multiplying by 12, right? And that's going to essentially give you how many months it is. It does look like it's still like a nasty amount there, but, sorry, interesting. Well, if you did 5.8 by multiplied by 12, that would give you like how many months in total there are, right? Yeah, so that's like, you gotta really talk about, you can talk about like 69 months or whatever, but maybe it's just easier to say, okay, 5.8 years, we'll just want the 0.8 part in terms of months. Doesn't end up being a nice number anyway, but that's how they want it. So we could say that that's the same as 5.8 years, or that's 5 years and 9.6 months. Okay. Does it say that there? It's the nearest month. So I guess we could say as what 70 months, or we could say 10 months. Yeah.
It doesn't want years. It strictly says to the closest month.
Yeah. So when it's
put it in months.
No, that's a good point, Willem. So Willem's raised a good point. He's saying, hang on, why am I right when the questions explicitly said, hey, we need it to the nearest month. But then how come you've written years as well? Like, that doesn't seem right. Okay. It's a good question. It's kind of like when they say, if you have some sort of dollar amount, 59, let's say 59.654, whatever, then when they ask you to round this to the nearest cent, well, they're not necessarily saying, oh, I only want it in cents. I just want it to the nearest cent. So they're saying, oh, okay, what's the nearest cent here? It would be 6.5, yeah? So this would be an acceptable response to the nearest cent. They're not just saying, I want it in cents. They say, I want it to the closest cent. Again, a lot of different ways you can do these. With part C, some people realize, hang on, if it's just a climb by the same amount each time, you don't really have to set up an equation. If that's helpful for you, you can do that. But there is kind of like shortcut methods you want to look for. One of the things that you can do, right, is you can do, okay, it's worth $3,200. And how much does it decrease by each year? It's just 250. So you can just divide by that, and that will get you the same kind of answer, right? Saxon, what did you get for that? 12 years, 12 years, well, if you round it up, yeah, it'd be 12 years. It's 12.8 years, remember? And so this is the conversion issue there, right? If we wanted to write it as months, yeah, you can multiply the whole thing by 12. And so you can write 153 or 154 months if you're rounding it up. But remember, I'm okay with you saying, okay, well, it's 12 years and 10 months if you want to round that up, right? So 12 years, 10 months. Okay,